So yes, I'm David Flores, and I'm going to be speaking about monitoring the network infrastructure and try to see if I can inspire a little bit about rethinking and giving some ideas on how to approach it with all these new AI agents, and automation, feedback loops, and all that kind of stuff to kind of put observability more into a first-class citizen. So a little bit about myself. I'm a network automation and observability engineer at CoreWeave, and I'm originally from Venezuela, and I'm based in Dublin. In Venezuela, I used to work heavily I started as a network operations engineer back in a service provider. So I had a lot of experience around service provider networks, ISPs, MSPs as well, and I came to Ireland to work with AWS, Amazon, then went to Bloomberg, some financial networks there, then went to NetUK3. I think some of you might know what NetUK3 as part of integration, solutions, and so on. And now I'm working with CoreWeave, which actually, can I get a raise of hands to know who actually knows CoreWeave? Okay, so what a few, awesome. They have the headquarters, they now have headquarters here in the UK, so we have offices here. And at the end of the day, for those of you who don't know, it's one of these neo clouds, it's just a fancy new word, but it's data center, hyperscaler kind of workload, but for AI, okay, GPU, at the end of the day. Now, you may wonder, why did this guy give me all his life experience? And it's to give you kind of a little bit of context of kind of my background and motivation working for day two operations and why I got into observability, which is a pretty niche aspect in the network world, okay, in the network industry as a whole. And to basically give you a little bit of feedback on why this presentation is tailored to inspire some new ideas on how to approach it, okay? So the very first thing that I have to set is the stage. We need to kind of speak the same language, okay? And the whole idea of this is come up with a proper statement, which is the gaps that we have today around network monitoring as a whole. We have these things that are infrastructure, either devices, virtual devices, whatever, that are emitting a lot of information to us in order to give us signal, okay? These signals are usually, telemetry signals that come from metrics, logs, flows, some SSH, CLI scraping capabilities in order to get maybe some synthetic monitoring, for example, or active monitoring from specific collectors. But the whole idea around this is just to get some data, okay? Get some data out of the infrastructure in order for you to actually make, take decisions, act on it, alert on it. And, at the end of the day, is basically understand how your operations are doing on a day-to-day basis. The problem that we have at the moment, okay, with the infrastructure, and I actually talk about my experience with NetUK because I joined NetUK a few years ago, well, more than a few, but most of the work was around as a managing consultant working with different kind of enterprises, from retail to normal corporate networks to service providers to data center, and we basically saw a lot of same commonalities of kind of like where we are at the moment with the observability space. And it's always an afterthought, okay? One of the main issues that I've seen today is that it's always coming observabilities after the fact that I already configured my network, that I already deployed my network, that I already designed my network. When the day-to-day operations, and that becomes like a problem because you basically are just patching your day-to-day operations at the end of the day, okay? Now, the three main issues that we have is with the current tooling that we have is around data diversity. So we have too many data formats, we have too many technologies in order to get that information out of a device. We have also, problems accessing that data. Most of these tools, and again, like, I don't want to give any shade to the existing traditional NMS tools at all. Actually, I think they're doing a pretty good job. But I'm just trying to highlight some of the shortcomings that are really crucial for kind of like jumping to kind of like the next phase, okay? Which is treating observability as part of the overall ecosystem of network management in overall, okay? And the access to the data is really crucial for that, okay? So, with all implementations around observability stacks, and also looking at what groups like the NMP or the ITF is, all the great work that they're doing in trying to normalize and standardize more of the two operations and the network management aspect of things. We try to come up with a way for us to tackle it, okay? That is, honestly, is rooted by the whole system engineering, compute, cloud native foundations, and see how we can actually leverage how they're doing, okay, their own day two operations, they're alerting, how they're collecting all the metrics and the logs, and see if we can actually, just reuse it, okay? So this is where the observability architecture came into place. The observability architecture at the end of the day is just building blocks. And actually, there's going to be a talk that Pete is going to be doing next around something like the NAF framework. And this is basically a zoom into the observability space. At the end of the day, breaking down the architecture or the problem of any monitoring observability tool into building blocks gives us a lot of advantages. The main one is decoupling, okay? Decoupling is key, and when I say decoupling is physical decoupling, like you need to talk from the data collection layer over to the data processing layer over the network. Because then you start talking about contracts and data formats that this is well known in the industry, especially on the system aspect of things, software development, system engineering. They have pretty well standards to basically make services talk to each other, understand each other, have contracts around how your data is going to be sent. So it's basically trying to reuse some of those capabilities and tooling that is already around it to build an architecture that is going to be scalable, okay? The other aspect of having a building block of it is that some of the biggest issues that I said, like data diversity, is easier to handle if you have just a building block that you just focus on how to tackle it. But because if you focus on, well, I have this data collection right now, and now I need to put my database in and then my visualization layer, and everything is a big monolithic application, becomes harder to scale, becomes harder to allow other protocols like GNMI, streaming telemetry, open telemetry, you name it, HTTP, just scripting. So I'm not going to go through all of these building blocks, okay? I'm pretty sure that these slides are going to be shared, but yeah, I'm going to dive in a little bit and over the next slides. So the architecture, okay, gives us three main advantages, okay? One is, I already talked about, diversity, okay? Diversity comes from the data pipeline. So from the previous slide, we saw data collection, processing, distribution. That's basically all of that here, but more in a serial manner, right? We collect metrics, we collect logs, we collect flows, for example. And at the end of the day, for us to actually, be able to funnel that information around, to be able to get common dashboards, common alerts for any vendor or any kind of way that I'm preaching the data, any kind of format the data comes in, because it might be coming from SNMP, it might be coming from a GNMI. I normalize it into a common data model, okay? That is really powerful, because not only gives you the capability of reusing these things, but also describes how your network is behaving, which then you can start using that to retrofit, for example, the configuration management piece. How you're going to be, in order for me to deploy safely, okay, a BGP peer exchange, and I'm going to be adding a new BGP peer, and I need to validate the ESNs, to validate the prefix that I'm receiving, you know already beforehand what kind of metrics you're going to be receiving, and you can actually add it into your post-automation checks, okay? The other aspect is enrichment. And enrichment is basically adding data that really matters to you, that matters to the business. It's a way to actually reduce the noise. Because if you put an alert right now over your blank network, of your network that is blank, that doesn't have any kind of connotation, or even doesn't have any kind of information about the roles that things have, then you're basically going to have a lot of noise, because some interfaces may be more important than others. And at the end of the day, having this normalization and enrichment gives a really powerful querying engine, okay? Let me talk a little bit about it. So if we zoom on the data normalization piece, we can see on the left a couple of signals, right? So this is just an example of a PromptQL style of metric. On the top, we see, for example, data coming from NMI, and the one on below is SNMP. You can see that they have some discrepancies, like the metrics come for the upper state. The field is basically has a value of a string. It says up. On the interface follows the MIB, so it goes with a number, EF upper status up. So at the end of the day, we want to be able to funnel that information through and just have one unified model, which is the one that we call normalization. And have an interface upper state, name Ethernet 153, value of 2. What this gives us is basically a commonality language that everybody understands, not only you understand, is also going to be useful for your other teams, SRE teams, cloud teams, whatever the environment it is. They're going to have now a common language that they can now look into and understand what all of these fields are, what they're supposed to be, and also it doesn't matter if it's Juniper, Arista, Nokia, you all have kind of like the same common language on the operation side of things. The next zoom is around the enrichment. And on the enrichment is the part where we add metadata. So where does the metadata come from? The metadata comes from a source of truth. And well, actually, there was a post in LinkedIn yesterday that I saw from Upsmill that says source of truth, and they scratch truth, and they put intent. And I love that, by the way. So thank you for that. I think it was right. Because that's exactly it. We're trying, at least on the observability side, we're trying to bring some of that intent over to these metrics, because that's how we enrich them. It's really powerful, the queries, filtering, and prioritization that you can actually give to your alerts if you add this kind of metadata into your metrics, okay? Now, the next point, around integrability. I hope I said it right, apologize. But one of the other aspects is that we have tools that are pretty close source, that all the components are kind of sitting together. So it's really hard for you to either like inject these enrichment labels, right? Or expand the diversity with other kinds of collectors. Let's say that you have a switch that has some engine is running a Prometheus exporter and it's posting those metrics. How can you actually start doing that with the traditional tools that we know? So that's the part of the integration. The system needs to be integrable in all its phases, in all its building blocks that I showed before. This is an example, okay? So right now, I've seen few presentations. People are using, well-known source of truth out there, like Netbox, Narbot, and InfraHub, which I think is great. And one of the few things is that there is a lot of value of having that data exported and also influence how your operation is going to go. It's not only like a database when I'm going to be storing my device and my serial number, and these are my cables. Or, for example, PBNDB, this is a good example. It's not only that, you can actually use that information to influence how the operation is going to do in a more automatic manner, okay? So the whole goal, for example, in this specific use case, is that you have a device, You put it into one of these systems, you put it in maybe in a plant state. At that level, you already know that you're going to get a couple of Juniper devices, you're going to put it in a plant state because you might be working on a branch, just to give you an example. And that means that you're not going to start monitoring right away, okay? You actually want to start maybe doing some ICMP checks from your observability system once you start putting into provisioning state. You start putting in provisioning state, you start configuring the device, you want to know if the device is actually reachable, and once you finish your configuration, your provisioning, then the device should be coming into a provision state because it's not ready yet, okay? Oh, but that means that I want to have telemetry. So you enable the telemetry. So the system should know all of these status changes coming from the source of truth, or better yet, the source of intent. And the whole goal is that having this synergy, and this is part of the ecosystem that I was talking at the beginning, is that observability and source of truth, source of intent, they become kind of like more synergetic between each other. One uses that information is used to enrich the inventory layer on the observability stack. The source of intent actually does that. Or feedback loop, which is the next one. Observability now is the one that is generating the action, okay? So you have alerts, and this is a good example of how you can actually start using observability outcomes to actually, influence the intent, influence what is going to happen from a reporting capability. But the whole goal is to be able to the system needs to be integrable from input and from output side of things. Now, to give you a concrete example of this, we did a workshop, which I'm going to put it at the end of the slide, by the way, in NetUK 5 in Munich, around network telemetry, and we actually finalized on this part, which is automation and creating an observability feedback loop. And this was the use case, actually. Verbatim. A BGP session is not up, okay? What can we do from an automation perspective, okay? And this is just an example of what you can do. You get information, you get evidence, okay? You get information from the source of truth. For example, InfraHub. For example, this is a BGP session from PeeringDB, okay? You get that information, you actively ask this information, and you put it into a bundle. Your Prometheus metrics are gonna tell you what is true, okay, what is happening, okay? This is what is happening right now at the device level. And Loki, for example, and I say Loki because this is just a log database, is gonna give you, for example, information of what just happened. Now, what you have here on this evidence is not only the alert, but also a bunch of data that is correlation, is going to give you way more information or analysis of what you can do after, okay? And then you can put whatever you want to put. An AI agent, for example, to help triage and run the capabilities, or if you already have run books or really well-known steps on what to do after because you have that in your design, you basically start creating policies. Hey, if this happens, try to do this and this and this. Silence, perform some action, send it over to an AI, okay? Another example of this could be an assisted RCA, root cause analysis. It's really, really powerful when you create that evidence bundle that I showed you before, and you send it over to one of these LLMs in order to give you an assisted RCA. Their analysis is really much on point. But it's not only the operational data that the agent is receiving, it's also getting information from your source of truth, okay? Great. And I don't want to rush here. Everybody good about at least the two main points, diversity and integrable. The observability side needs to be integrable. So those two. Now, scalability, which is the other big one. When we talk about scalability, we often think that can be, oh no, I need David, you're telling me that now I have to deploy Telegraph, Prometheus, Grafana, Loki, Alert Manager, all of these components now, and I need to grow them individually and I need to manage them. It's going to be a lot of operational overhead, and you're not wrong. The main thing here is taking a look at the observability architecture. You're not alone, okay? You may have already a system engineering, compute team, storage team. They already are using and maintaining these tools, or a lot of these tools, at least the back-end side of things. Databases, the visualization, like Grafana, for example. Or if you come from the Elastic side of things, Kibana. And they already have, a lot of legwork actually in front of us. They already have a few steps ahead on how to manage it, how to operate it, etc. So if you really think about where we are in this star, which is on the collection of the processing of the data, which makes sense. This is our field, right, from the network perspective. This is where we are the ones that know SNMP. We are the ones that know GNMI, or at least should. But we definitely are the ones that we care about this data. So this is where your expertise is needed, okay? And that's the part that I actually want to convey here. Like, you don't need to build the entire thing. You just basically need to focus on where you can actually add value and reuse, break those isolations between other teams with other teams, and try to communicate and work better to, provide a holistic observability solution, okay? Now, the other aspect is, of course, like that helps, okay? We reduce it a little bit. But what does that mean? Now, still, I have hundreds of collectors. How can I start putting them all together? Like, how can I grow them? So one of the few things, the strategy of a start small, scale horizontally, works pretty well with a lot of these tools, okay? Because they're purpose-built. Like, to give you an example, Telegraph is great at collecting data with SNMP, GNMI. Telegraph is a product, for those of you who don't know, you may know InfluxDB, so it's part of their offering. It's an open source tool. And we heavily use it in the workshops and in the book. But it's kind of like our day-to-day. That's where we are most of the time, trying to collect more data, normalize it, enrich it, and everything done at that instance, okay? And we can grow that horizontally. There are multiple ways to do it, and some really good articles about it too. The storage, this is more for maybe your backend teams, the system engineering teams. But that can grow too. Like companies, like you can either grow horizontally if you go full open source, or if you manage to get some budget, maybe you can get something with Grafana Labs or something around those lines that can give you the databases, the whole observability, like all the backend, like from Prometheus. Well, they have Mimir, but at the end of the day, it's a time series database that is talking PromQL. It's kind of like the same language. It's a universal language from a metrics and observability perspective. It's part of the Cloud Native Foundation as well, so it's really well known. There's tons of documentation and support around it. So it's trying to leverage some of these capabilities from these teams in order to, so you don't need to build it yourself completely. And this slide actually is more around how to get started. And this goes back to the fact that you don't even need to build like the entire solution right now. I know that I have people reached out multiple times to say, hey, I want to reach out, but I'm having issues scaling it. I can guarantee you that a server with just a single Docker Compose, with a lot of these components, these example components over here, built into it, is able to handle thousands of devices and metrics, and it's going to give you at least the day-to-day, your hot days, your day 2 operations are going to feel better, way better for it, okay? And the whole thing is that you don't even need to have the entire stack running. You can even, get one of these foundational observability layers, like the data processing layer, out for an MVP. You don't need it. You might be able to just, hey, start with Telegraph, start with something vector, which is something that I started using lately in CoreWeave. It's amazing. I love it, honestly. But it's a way for us to actually collect data, logs, metrics, normalize them, and put them into our day 2 operations, okay? Awesome. So, well, to wrap it up, okay? And I went a little bit more faster than I wanted, but just wanted to give you a few links, okay? The first one is basically some of the books, some of the information that Christian is the co-author and my brother in arms in this area around network observability and automation. And we have tons of podcast sessions. We did one with Cisco DevNet where we went deep dive into one of the examples of these scenarios with real life, because the full lab is actually a lab that has container lab, it has some network devices there, and you can actually just go through the whole cycle from collecting metrics all over to automating something with them, okay? And we ran a workshop in AutoCon 5, and in this workshop honestly, it's pretty lightweight, okay? The format is basically completely on the observability side of things. It's completely self-paced. You don't need to have us basically presenting it, because a lot of the information, all the information actually is there. So I invite you to actually take a look at it, and you can run it in your own laptops, honestly. So there's no need to actually have some specialized hardware. The full lab, though, definitely needs some compute and memory resources, but not too much. And well, that's it. Thank you very much.
Thank you, David. Any questions? And just a little hint, if you are asking a question, get really close to the mic. That helps us hear it better. Thank you.
Very close. Oh yes, that works.
Spot on.
Thank you.
Yeah, I'm Tim Chown from JISC. We're the UK National Research and Education Network. Other NRENs are working on something a bit similar to this called Metronova, which is collecting data in a similar way, putting it all into ClickHouse. One of the challenges we have, though, is sharing the data between different NRENs. You've talked about scaling across. What sort of thoughts would you have about how you classify the different types of data you're collecting, some of which may be more PII, like net flows versus traffic counters, and some sort of policy-based sharing capabilities?
Okay.
This is kind of pushed towards more single domain, I think, but if you've got multiple domains and you want to do end-to-end troubleshooting between, say the US and a country in Europe, and the data's going through 5 NRENs, and we want to be able to pull the data from the different sources to analyze. Do you have any sort of advice or thoughts on that?
Yeah, I do. And that's a great question. Thank you for it. So I don't know if you have heard, but there's this mothership architecture, especially on the observability data pipelines, where you basically put collectors and some of the backend close to the source as possible, as closest to the source as possible, especially if you have links that are kind of lossy and you don't know if you're going to get some of the telemetry data out, you don't have any kind of reliability there. Like, for example, if you're trying to do SNMP probes over to, it has happened like to remote regions, and you don't get the entire data set. Trying to put it closer to if you have a rack there, just put a server there, just to get some collectors going, because the whole thing is that these systems are built in a hierarchical manner in order to scale, okay? So they actually do a pretty good job for replicating the data and aggregating the data from one backend over to another, okay? So solutions like Mimir, Thanos, what are we using? Metrics. They actually provide this capability already, okay, from that point. There's another approach too, because if you have this latency as well, you can also wrap it up, like just put the collectors there, and the connection back to your central observability stack that can be secure, and you can actually have like either expose it, do just a TCP connection over it, and just forward all the metrics in a little bit more reliable manner. That also helps a lot, because you also get all the metrics collected and computed at that remote location, okay? We call it like the mothership model, but that's one way to do it.
Okay, thanks.
Yeah.
Greg Choules, ISC. When you saying you would normalize all the various data sources into your standard model, supposing a source comes along which has a new type of data that you don't have in your model, do you have to then redesign your model?
No. So that's a great question. So the approach that we do on the modeling is we go through the standards. The best one is SNMP. The MIBs actually are pretty well matured, and they provide really well, semantics about the data. We use that as our source of truth, actually. That's our baseline. And then based on that, we start creating our models. Now, we version them. So that's the key aspect. So if we need to have an update, we version them. So maybe we have the interface model in version 1, which is basically what it's a copy-paste of SNMP. But some vendors want to add something extra, which is needed, okay, for some of the observability data, and we version it. So, okay, we need to update the model with this new attribute or whatever, or child, and then based on the new version, we roll out the new version. And we can just, based on the versioning, we kind of keep history of these changes, and helps the rollout like normal applications would do with the new versions.
Got it, thank you.
Yeah.
Excellent. Any more questions? If not, thank you very much, David.
Thank you.